Hi, in this lesson we are going to go over the basic arithmetic operations from Kusyar bin Labban given in section 2.2 of the book. And the operations are of course addition, subtraction, multiplication and division. There is also operation of halving, which we can consider as the fifth operation. So as stated in the book, these algorithms are described for someone who would be working on a dashboard. So each column in the succession of the algorithms represents a snapshot of the dashboard. So the person would erase the dashboard from one figure to the other. Okay, so we're going to illustrate these algorithms by examples. And for addition, let us consider, so let us say we want to add the number 7,938 and 547. So there are similarities and differences between the algorithms described here and the way you do these operations in school. Okay, so he puts these numbers in two rows and they are aligned from the highest common position. So in this case it is 100, so 5 goes underneath 9. So he places the numbers like this. And one difference between this algorithm and what you learned in school is this one starts from the leftmost position as opposed to right position. And also at every stage the number on the top will change, and eventually at the end of the process it will contain the result. So the number on the top will be replaced at the end with the sum of these two numbers. Okay, so starting from the leftmost position, so we want to add 5 to 9, or we can consider adding 5 to 79. Especially when the result is going to be greater than 10, you can just consider adding to the number two digits, the number above 5 and the digits to the left of 9. So of course 79 plus 5 is equal to 84. So we are going to replace 79 with 84 in the next stage. So we would have this. You see in the dashboard, this would be the initial configuration on the dashboard, and this would be the next stage. Okay, so now we continue to the right. So now we add 3 and 4. So in this case the result is single digit, so we just replace 3 by 7. So 3 plus 4 is 7. So we have 8, 4, 7, 8, and 547 in the bottom. That is not changing. And finally we add 8 and 7, or you can consider adding 7 to 78, and the result is of course 85. So we get 8, 4, then 85, and 547 in the bottom. So now we are finished adding every digit of the number below to the number above, and at the end of the process we obtain the answer on the top. So this is the operation of addition. I think it is pretty straightforward. As an exercise for yourself, so try adding 7 to 2038 and 56,419 using this algorithm. Of course, without using any calculator or anything else, make sure that you apply the algorithm and obtain the correct answer that way. Okay, so next let's consider the operation of subtraction. Okay, this is similar. So let's say, again, let's explain this with an example. And let's say we want to subtract 625 from 5,316. So 5,316 minus 625. Okay. Now we place the numbers as we did for addition. So we put them in two rows. 5,316 and 625 in the lower row, and they are again aligned from the highest common position, in this case hundreds again. Alright, so and we start from again from the left and subtract 6 from 3. Well, since 6 is greater than 3, instead of subtracting 6 from 3, we are going to subtract it from 53. So instead of borrowing, we'll be just subtracting from the two digits. So therefore, our first step is subtract 6 from 53, and of course the result is 47. So we are going to replace 53 with 47. And this is the first step of the algorithm. So the next step is, go to the right and do the same thing. So we want to subtract 2 from 1. Well, since 2 is greater than 1, instead we are going to subtract 2 from 71. So this is just subtracting from the two digits. This replaces the borrowing that we do in the modern, the subtraction that you learned in school. So 71 minus 2 is 69. So we are going to replace the middle 71 with 69. Okay. And finally, we are up to the last digit. We are going to subtract 5 from 6. And that's pretty easy. It is 1. That means that we are going to replace this final 6 by 1. Okay. And again, as in the addition, the answer is obtained on the top row. So the top number, the original top number, is replaced with the answer. All right. So now let's move on to, before multiplication, let's move to the operation of halving. Halving means given a number, find half of it, right? Now we are going to consider a few cases for this operation. The first case being the easiest case, where all digits are even. Let us say we want to find half of the number, let's say 648. So again, he's going to do this in steps. He'll be working one digit at a time. And this time he starts from the rightmost digit. So in this case 8. So he simply, when all the digits are even, you simply divide each digit by half, and that will give you the answer. So the half of 8 is of course 4. So the last digit is 4. Actually, since Arabic goes from right to left, they would call this the first digit. Okay, so we need to be careful when we say first digit and right digit, last digit in this context. Okay, so then we move to the left, to the middle digit, and take half of that, which is of course 2. And finally, the leftmost digit, 6, so its half is 3. So therefore, the half of the original number, 648, is 324. That's pretty clear and obvious and easy. So, and we can see that the result, the answer is correct. Let us now see what happens if one of the digits is odd. So, let's say some of the digits are odd, but not the units. So let's say the number contains some odd digits, but the unit digit is still even. Well, let's see what we can do in this case. So let's take this number, let's say 638. Okay, so we operate the same way. You know, we start with 8, take half of that, which is 4. Sorry, it's 4. So let me correct this. It is 4. Okay, next, we want to take half of 3. Well, 3 is an odd number, and half of 3 would be, 1.5. How do you do 1.5? Well, instead, we are going to remember that this 3 really represents 30, right? It is in tens position. And we know that half of 30 is 15, right? So what we can do, so 15, this 5 can go to the units digit, and we can put a 1 in place of 3. So we can go 6, 1, and then 4 plus 5 would be 9. Okay? And then finally, we can take half of the leftmost digit, and it's of course 3, and we are finished. So half of 638 is 319, and of course it is easy to verify that this is the correct answer. Now let's look at the case where the last digit is odd. Well, let's be more careful and say units digit is odd. Oops. Okay. So units digit is odd. Okay. So let's consider the example of having the number 125. Okay. Now let's start with 5. And 5 is an odd number, right? So, and half of 5 is 2.5, right? So how do you write 2.5 here? Well, the thing is, we need to go to the fractional part, right? So now we need to have a half. And here, Kushyar does something interesting. So, 5 over 2 is 2.5. So what he does is he replaces 5 by 2. Now how does he handle the half? Well, he uses for the fractional part base 60 system. So we are going to, learn about base 60 or sexagesimal system in more details later. But for now, he takes advantage of the currency system at the time, in which 1 dirham is equal to 60 flus. So because of that, he finds using the base 60 system more convenient. So consider, half a dirham. So if 1 dirham is 60 flus, then what is half a dirham? Well, it is of course 30 flus, right? So for the fractional part, half, he simply writes a 30 underneath. So again, this 30 represents 30 out of 60, which is a half. Okay. So after that, he moves to the next digit and have that, which is of course 1. And he just keeps the half in the bottom. And finally, let's have the leftmost digit, which is again an odd number, 1. So how do you go about having that? Well, this one, remember, represents 100, right? And 100 over 2 is 50. So what we can do, if we add a 5 to the digit in the right, and then this becomes 0. So we can just make this digit 0 and add a 5 to the digit in the middle. The digit in the middle is tens, and adding 5 there would, represent 50. So we would get 62 and 30. So basically the half of 125 is 62 and half, which is of